Hi guys, welcome back to my YouTube channel. In this video, we'll be starting phase 1 where we will be looking at multiple data points. In the previous video, we just took one data point and we tried to calculate the weight for that model, which is y is equal to wx, by performing 3 iterations and taking a learning rate of 0.3. So now this video we will have a shared weight. All the data points will have a shared weight, but we will take multiple data points. So the first data point is x is equal to 1 and y1 is equal to 2. Second data point x2 is equal to 2, y2 is equal to 4. Third data point x3 is equal to 3, y3 is equal to 6. So by now, for the model y is equal to wx, you would have already predicted that the weight for this model would be 2, because if I take the first data set, first data point, y I'm substituting it with 2 is equal to x I'm substituting it with 1, so w has to be 2. In this video, for these multiple data points, we will calculate average loss and we will also calculate the gradient for the average loss. So I'll go to the next slide. Over here, if you see, average loss is nothing but we will calculate the average for the loss function. So as we already know, the loss for this function is L is equal to y minus w x whole square. Let me quickly grab a pencil. So the value of loss we already know, it is y dash minus y whole square. So that is what I'm trying to do over here. If you see, I'm pointing it, but y I'm substituting it with wx, because that is the value, that is the model. So now if you see, that is why I have written y is equal to average of 1 by 3, because there are 3 data points, and I have summed y minus wx for all 3 data points. I'm quickly grabbing the highlighter, just for the sake of pointing it. Okay, so here if you see, I'm trying to calculate the average loss. As I have told, I have already told you why I'm substituting y minus wx over here. So if I expand this, 1 by 3 will be out here common. I'm opening a square bracket. I'm substituting the first data point here where y is equal to 2 and x is equal to 1. Y minus wx will whole square will be 2 minus w whole square, and plus 4 minus 2w whole square, because in the second data point y is equal to 4 and x is equal to 2. That is what I have substituted over here. And in the third data point, y is equal to 6 and x is equal to 3. That is why 6 minus 3w whole square is here. So this is the value of average loss. And jumping to average gradient, we have already known from our previous video that for this model and for this loss, y minus wx whole square, the value of gradient dl by dw would be minus 2x into y minus wx. But here we are trying to calculate the average gradient for 3 data points. Hence it is going to be 1 by 3, basically dividing the sum of all the gradients by 3. In this there is minus 2 over here, which is a constant. I'm trying to bring that out as common, so minus 2 by 3 square bracket into this expansion, it is going to be x minus y I minus wxi. So first data point, as we already know, x is equal to 1, y is equal to 2, so that's what I'm trying to substitute over here. X is equal to 1 into 2, which is the value of y, minus wx. X is 1, so it is going to be just w. And I'm substituting the values of second data point over here. 2 into 4 minus 2w. 2 is the value of x, 4 is the value of y, minus 2 is the value of x, and w, we do not know the value yet, so I'm just putting it as w, plus 3 minus 6 into 3w is the third data point substituted. So 3 is the value of x, 6 is the value of y. Hence we have arrived at an average gradient. So guys, for this, what you can do is, from the previous example, you already know you can take a learning rate of 0.3, or if you want to perform multiple iterations, if you're okay with it, you can take a learning rate of 0.1, and you can start with a weight of 0, and hence you can perform multiple iterations, 1, 2, 3, 4, 5 iterations. You can set your limit and try to find the weight. So what varies from the previous video and this video is that in the previous video we just took one data point and performed multiple iterations of the training loop. So basically we calculated the loss, we predicted a value, for that value we calculated the loss, and then we calculated the gradient, and for that gradient we also calculated the gradient descent to find a new weight. Here we have calculated till the average gradient. The formula for average loss and average gradient has now changed, so we will use these to perform steps 3 and 4 to find a weight, guys. That's it for this video. Thanks for watching this video, guys. If you have any doubts, please drop in the comment section. Also, kind note that by recording this, I'm actually new to YouTube. I'm trying to record videos. I'm trying to teach something that I'm learning as well. I'm a beginner to machine learning as well. I might make any mistakes while teaching you. So the whole intention of this channel is to not just teach you, but also to learn from all of you. So if you have anything to share with me, please do drop in the comment section. I will read each and every comment. Thanks a lot for watching, guys. Have a great day. I'll get back to you with a new video. Bye bye.